It is an enormous pleasure to welcome Professor Michael Loui here to speak with us this morning. Many of us have known Michael for a very, very long time. He was for many years a professor at the University of Illinois in the electrical engineering department, which is electrical and computer engineering department, which is very near and dear to my own heart, of course, as an alum of that institution. He was also dean of the graduate college and then also held a distinguished professorship at Purdue University in engineering education, which has really been one of his specialties over the years, and also one of the nation's foremost experts in thinking about ethics and professional responsibility within engineering education and the engineering profession. And with that, I'm going to hand it over to you and let you take over. And just to say again, thank you very much for volunteering to come in and speak with us this morning.
Yes, thank you. Thank you very much for that kind introduction, Clark. And it really is a delight for me to be here on the Tempe campus. So today I'm going to present a paper that is under peer review for a journal publication. How do engineers understand and experience ethics in professional practice with implication for education? Even if you're not interested in engineering ethics education, I thought you'd be interested in our research methodologies. If you are interested in this topic in education research, and you're not interested in engineering, that's fine too. Just think, substitute another profession and see what that works. At least for those who are employed, right? So, let's see. So this is joint work with Nick Fila, Carla Zotowski, who are two first co-authors, and then Justin Hess, Allison Kerr, DeYoung Kim, and Andrew Brightman, who is in the senior position of the last author, as PI of the supporting grant. I am the sixth of 7 authors on their paper because I know the least about this project. So be careful of anything I say. The paper is under review and we would benefit from your feedback. So accreditation criteria for engineering programs have required ethics for many years. The ABET, which is the accreditation, formerly the Accreditation Board for Engineering and Technology, has had a requirement since before, at least 1986, where they said an understanding of the ethical, social, economic, and safety considerations in engineering practice is essential for a successful engineering career. Coursework may be provided for this person, but as a minimum, it should be the responsibility of the engineering faculty to infuse professional concepts into all engineering coursework. And then the ethics requirement was made explicit in more prominent in the EC 2000 set of criteria. This brought outcomes assessment and criterion 3F, which states that engineering graduates should demonstrate an understanding of professional and ethical responsibilities. And then there was another related criterion, the broad education necessary to understand the impact of engineering solutions in a global economic, environmental, and societal context. So here the standard is just understanding. We don't expect you to behave ethically, which is actually pretty hard, but at least an understanding. Then the new criterion adopted in 2019 requires an ability to recognize ethical and professional responsibilities in engineering situations and to make informed judgments. So now we've ratcheted up to at least the ability to make informed judgments. Again, whether you do or not, that's another matter. Now, engineering ethics instruction usually starts with the story of a famous disaster, which highlights the engineer's role in ensuring safety. In aerospace engineering, the touchstone case is the explosion of the Challenger space shuttle. Other touchstone cases would be in civil engineering, the collapse of the walkways of the Kansas City Hyatt Regency in 1971, 81. The collapse killed 114 and injured 216 persons. Then in mechanical engineering, probably the explosion of the Ford Pinto gas tanks, quite dramatic. And then say nuclear engineering, the 3 Mile Island accident. So there are lots of disaster cases, but and cases of disasters provide at least memorable stories, but do not capture the ethical issues that engineers encounter in everyday practice. So if we want to better align ethics instruction with the needs of professional practice, we need to determine empirically how engineers actually experience ethical engineering practice. So our research question is, in what ways do engineers understand and experience ethics or ethical engineering practice? Our goal is not normative. We're not interested in determining what engineers should do, but describing describing what they actually do. So, okay, first question. What do you think we found?
Engineers say they never make ethical decisions.
Engineers, I'm sorry, can you?
Engineers report that they never make ethical decisions.
Engineers report that they never make ethical decisions. Okay, well, that's, yes, Karen?
They talk about safety a lot, but they may or may not think about it as ethics.
So they talk about safety a lot, and they may or may not think about ethics.
They may not think of safety as.
Safety as ethics, okay, yeah, so safety as ethics, yeah. So that's possible.
I'll go something with a different direction. They found that they are ethical anyways.
They're ethical anyway. They don't need instruction or whatever.
Yeah, it's like,
My definition is ethic.
Yeah, of course.
We are in a profession that's devoted to the good of society and all
Yeah,
professions, right? So therefore, we must be ethical. As professionals, we must be ethical. Okay, so those are a range of things. So we're going to actually.
Mostly it's a financial.
Financial, yes, the financial considerations, yes. So, as usual, the story, I love Gustavo's answer to a question I had earlier. It depends, right? All graduate students know that that's the right answer to every difficult question. Our research methodology is called phenomenography. Now, you may have heard of phenomenology. Now, that's a research methodology to understand the essence of an experience of a phenomenon, such as the experience of surviving breast cancer, right? So people would study that particular experience and look for the essence of it, a short description, sort of singular description. We're interested actually in phenomenography is to go understand the range, the qualitatively different ways in which a person experiences a phenomenon. So it aims to understand personal experiences, but the variations in different ways that people experience a phenomenon. This is a methodology that's wildly popular in engineering education research. There might be a methodology you might be interested in adopting at some point yourselves. So the outcome here, we want to have some just categories of description. We have all these different experiences. Can we categorize them into a reasonable set of categories, usually 3 to 8 categories, and then some dimensions of variation. Ideally, there should be a range of experiences, and so that you can order the, let's say, 8 categories along one axis from simple to complex or something, maybe a second axis, and that's the dimensions of variation. So some basic assumptions. First assumption is that people can reliably interpret their experiences of the world in terms of their facts and values, which are interrelated. So we're not going to try to disentangle facts from values from people, and we're assuming people are reliable because we're going to depend directly on what they say and interpret their experiences. And then each individual's experience, the assumption is going to be aligning with one of these categories of description. So the idea is we'll have all these different experiences, which we get from interviews, and we try to categorize them at the sort of whole person level rather than like coding or something like that. For trustworthiness, it's a qualitative research method, so we don't talk about validity, we talk about trustworthiness, and we're going to use the Q3 framework, or QQ. This is a process-oriented framework that's inspired by quality management, very popular in engineering education research. I think this is going to be our most important export from engineering education research as a way of ensuring equality in qualitative research. So the validation process is how can we improve the capacity of the research findings to capture and represent the observed social reality, right? And we want to be as faithful as possible to what we're observing. There are 2 phases: making the data, which includes activities in research design and data gathering, and handling the data, which are the activities of interpreting the data, generating knowledge claims, and representing and disseminating or publishing the results. So, and what this framework does is it has several concepts, constructs. And it's a systematic way to promote trustworthiness. It incorporates practices you might already use if you're a qualitative researcher. And there are questions for each stage of making the data and handling the data on these 5 constructs. Theoretical validation is, do the concepts and relationships of a theory, if you're using an underlying theory, correspond to the investigated social reality. So one example might be purposive sampling. You're sampling from the cases that you look at as are informed by the theory, right? If you think there demographic differences might affect your results, then you want to make sure that you have different kinds of demographic categories represented. Procedural validation. How does the research design to improve the fit between reality and the theory? How can we mitigate threats to the authentic view of that reality? So for example, you might already use triangulation with multiple sources of data, or you might already search for disconfirming evidence. That's just a practice that is classified as procedural validation. Communicative validation is a socially constructed knowledge. And remember, this is socially constructed by the researchers, meaningful to the relevant community. So for one example would be pilot testing an interview protocol. Does it communicate with the people that whose experiences we're talking about? Pragmatic validation is, do the knowledge claims withstand exposure to the investigated social reality? What assumptions does our research approach make? So we're being explicit about our assumptions, and we're checking back to see whether it comports with the social reality. You might already do something called member checking, where you check whether results make sense to the people whom you studied, or in our case, it would be a representative sample. And then process reliability. How can the research process be independent of random influences? How can we ensure consistency in a process of interpretation? How can we demonstrate the dependability of our processes? So for example, you might write reflective memos during data collection to check your biases. So just being completely explicit about what you're reflecting on, your underlying assumptions or aspects of your identity that might affect how you interpret the data. And later we'll show how we promoted each of these constructs. So our source of was 43 engineers in the health product industry. And these were, well, it was, we had connections with the health products industry, so that's why we went after that. But we tried to select a range of engineers within that. So there were semi-structured interviews, each 90 minutes long, which started with the a question, can you describe an experience that you've had with ethics in engineering? And then many follow-up questions to elicit more details about the experience, how the engineer felt, what the engineer did, and so on. These were employed in several different firms in the health products industry, orthopedics, pharmaceuticals, medical devices, with whom Dr. Brightman had a prior connection. So in that sense, it was a convenient sample, but we administered a survey first and got volunteers that we could select along different demographic categories. So we want to maximize variation in gender and other demographic attributes, because demographics is known theoretically to affect moral attitudes. There were 30 men and 13 women, which is not bad. So women were definitely represented in the sample. The age ranges, so a lot of younger engineers, some right out of college, mid-career, and a few older engineers. If there are students here or watching, I love horizontal bar graphs. Then you can have a nice long label on the left side and not squish it in if you have vertical bar graphs. So if you learn one thing today, is consider horizontal bar graphs. As you might expect, the number of white respondents was fairly large, but we had representative from Asian, Black, and multi-racial respondents, informants. Years in engineering, somewhat overrepresented in younger engineers, but that's okay. Remember, it's not a representative sample. It's just we want a range of variation of different levels of experience here. And then disciplinary training from agricultural and biological engineering, materials engineering, industrial, multidisciplinary or interdisciplinary engineering, electrical and computer engineering, chemical, mechanical, and of course, as you might expect, lots of biomedical engineers in the sample, set of cases, it's qualitative research. And then the highest degree, advanced degrees are somewhat overrepresented in this group of engineers who we interviewed. The roles in the company vary from regulatory to quality control, research, manufacturing, and then design and development, large percentage in design and development. So we analyzed the data exhaustively. We read each transcript in its entirety. So we want to look at the whole transcript level and categorize it at that level. We organized the transcripts. And each 90-minute transcript, 90-minute interview produced a transcript of about 10,000 words, which take about 30 minutes to read. We got 43 of these interviews, right? And so that took a long time to read, and then organized the transcripts into categories, reread each transcript, adjusted the groups, then tried to write a description of the category based on commonalities, and then we could look at the differences between the categories. So that's our dimensions of variation. How do they vary from one category to the next? And then we checked the transcripts for alignment with the categories, and then we iterated because we critiqued each other. There are 7 of us, and I remember looking very carefully at the borderline cases and trying to make judgments of where each transcript or engineer fit. For theoretical validation, we use purposeful sampling along 9 demographic attributes, and we perform this thing called analytic induction, which is a fancy term that says we started with the data to create our categories. That's analytic induction. Nice fancy term for pretty common sense kind of thing. That's what social scientists do. We just use fancy terms for everyday processes. Procedural validation. We were immersed in the data for a long time. We iterated through categorization, recategorization, reinterpretation over and over again. So, we collected the data in 2016 to 2017. So it's been a long time. The paper's under review finally, and we have to revise and resubmit. So the revisions under review. So it's taken a long time. Communicative validation. We did pilot interviews with employed engineers. So that's at the level of making sure we are communicating with the participants, representatives of the participants. And then we gave presentations at conferences and workshops where we communicated with our peer researchers and asked them for feedback. This all makes sense. This could be a form of communicative validation if you can tell me whether what I'm saying makes sense or a few questions, and we can clarify. Pragmatic validation. Oh yeah, we got feedback from the Industrial Advisory Board, and it says it matched their experience as professional engineers. And then process reliability. We had a very rigorous development of a common interview protocol, even though there were 4 interviewers. There were generally 2 persons at each interview, so that again helps with the reliability. We wrote reflection memos for conscious awareness of our potential biases. We had peer critique of the pilot interview, as well as peer critique of the analyses among the 7 of us with extensive cross-sector checking. So this is our outcome space. And I'm going to describe, we've got 6 categories and 2 dimensions of variation. I'm going to describe each of these 6 categories. And they sort of increase from, on the vertical axis, from a greater awareness of sort of systems considerations. And then from left to right is more on the level of their understanding their roles and responsibility within this complex industry ecosystem. So, in answer to Jamie's point of whether they never have ethics, most of them said they have ethical issues practically every day. So, but the way they understand it is varies from one engineer to the next. At the basic level, category A, they just do the right thing, doing the right thing. So I'll read you how we describe it. Engineering practice is doing the right thing in the right way. The right versus wrong actions tend to be clear. So reporting data accurately, correctly following rules, guidelines, standard procedures, complying with regulations without questioning, even when it's inconvenient or difficult, seeking guidance and passing responsibility to others when the work is outside their expertise or responsibilities. One key feature of professionalism, as you know, in professional ethics, is competence. If this task is outside your competence, you need to get help or pass it to somebody else who has the right qualifications. So a quotation from a participant. There's always those things where you look at some numbers and you would say, if I would just put them down slightly different, it would make my life a whole lot easier for this project. But it's really the ethical thing to do, and the right thing to do is just to report it as accurately as you can. Nothing wrong with that, just being accurate. So, and for some engineers, ethics begins and ends with compliance, right? So safety is very important. And they know, everybody says patient safety, surgeons, safety, other people, but, and they do think of that as part of their ethical responsibility. But for some, this is it, right? It begins and ends with compliance, which is, I don't think is necessarily bad. Samuel Foreman once wrote that regulations such as building codes have supplanted individual conscience in ethics decisions, in many routine ethics decisions. So this is kind of base level. These tend to be the younger engineers, but not always. So that's our basic level. Category B now, ensuring integrity of the process. So now we're interested not only in outcomes, but processes, and realizing that guidelines, rules, regulations might require interpretations. So it might not always be clear. Let me read here's our description. Ethical engineering practice is ensuring there's integrity and quality within the process in addition to the outcomes. So it requires interpretation of guidelines, standards, and regulations, and understanding the underlying intent and purpose of the process to know the right thing to do. It's also holding each other accountable to right practices and principles and doing what you said you would do. So there's more of an emphasis on process here, of working with others to get the right interpretations. Here's a quotation from a participant. Countries outside the United States maybe don't have the same standards or expectations that we do in the US. But as a company, we expect our sites outside the US to follow the same safety standards that we do in the US. So sometimes that can be a little difficult just to help them understand it. Especially some of the newer people that we have that might not be, or again, as like I said, in other countries, not be familiar with our expectations. So in addition, another participant said, so we have procedures and we also have our regulatory requirements that drive our work every day. So try to be very conservative in reading those requirements, because a lot of times they are gray. They're not always specific until you knew what to do. So there's a shift here from category A shift from acting, you just do the right thing, do what the regulation requires, to decision making, which requires some interpretation of what the standard or regulation is, and that we also need to understand the reasons for the rules to do the right thing with integrity. For example, category A says we just need accurate documentation because you have to be honest, it has to be accurate. But here, people in this category would say, well, we have obligation to other engineers. So there's an awareness to interdependence between engineers and managing the process, not just the fact that the data are accurate, but it's part of the process of our obligations to other engineers, but still very local. Category C, upholding professional responsibility. So here's our description. This is a higher level of awareness and responsibility. Ethical engineering practice is upholding professional responsibility to the public, society, and environment, especially to the safety of patients, despite ambiguities in the regulations, uncertainties in the data, and risks in the outcomes, by relying primarily on technical and professional knowledge. Often there's frustration with tensions within the organizational context, conflicts among managerial, business, regulatory, technical priorities. So for example, time and cost versus technical quality, the classic kinds of conflicts that you might see, and then standing firm on engineering principles. So for this category, ethics is experienced as conflict. There are conflicting interpretations of regulations because they're ambiguous, conflicting values because the managers want to ship the product as soon as possible and start accumulating revenue, but the engineers are concerned about technical quality. This is, I guess we like to say well, let me give you a quotation from a participant. I think that as engineers, we have a special responsibility because a lot of the time we're responsible for ensuring the safety of a product and ensuring that the product is going to perform as intended. And we're kind of, in many ways, they're sort of the last kind of gatekeepers of that. There are other roles, obviously, that certainly influence it. But from an engineering technical standpoint, we're obligated to ensure that we're making the right product, we're making the right product for the right, in the right way, for the right reasons. So differing from category B, because of heightened sense of professional, now they mean technical responsibility, beyond simply being beyond integrity, and there's a more critical awareness of the tensions and conflicts within the organization between conflicting values. This category is the classic good engineer in the engineering ethics literature, right? Sometimes you talk about the heroic engineer who has to blow the whistle because safety is so important and the management's not paying proper attention. So this is one level of understanding what ethical engineering practice is. It doesn't exclude the more elementary levels, so it's more comprehensive, right? We say, yes, of course, the data have to be correct because we have this obligation to safety. And even if management wants to ship faster and use cheaper parts, we have to be firm on what the safety requirements are. Category D, here's a description, is so here we're trying to reconcile those different perspectives or different values. Ethical engineering practice is seeking to understand why they're doing what they're doing. The engineers are why they're doing what they're doing, and that they're doing the right thing for the right reasons, seeking to resolve uncertainty by appealing to knowledge and perspectives of others, while at the same time reconciling these with the internal perspective, the moral compass, and their emotions. A recognition of the need to always be in learning mode and that perspectives can change, seeking to convince oneself and often others of the logical, rational, acceptable, ethical path, and when disagreements or conflicts arise, to push back or accept that's not their role, is that. So here, this is trying to not simply saying the technical quality is the only thing I care about, but okay, there are other perspectives, and those are legitimate too. And how can we find a path that respects all those perspectives, reconciles those? Here's a quotation. Other people bring up different points of view, like, have you thought about X, Y, or Z? Or have you presented it this way? Have you talked to you know who? And so at that point, you can talk to management, maybe bringing in some of the technical experts that have been here for so long. That's also a path I venture. Also going to other people, so other people is important, and seeking their special help to present your case and help push it forward. If you get a lot of no's, then maybe your moral compass is a little off. Maybe you're not really understanding the whole process. My moral compass says to do something to help. If facts say I can't, I get frustrated, I get angry. You're trying to do your job without hurting the company, without hurting the patient to your best of your abilities. So differs from category C. Both categories have this critical awareness of and frustrations with tensions and conflicts within their organization, but they appeal to different sources and guiding principles to reconcile and guide decision making. For category C, the technical values are their first and sometimes only priority. That's their job, is to advocate for the technical quality. Here, these engineers try to find the right way while reconciling all these different values. In category E, now we understand ethical engineering practice is negotiation and using judgment. Ethical engineering practice is using professional judgment and purposefully negotiating with multiple stakeholders to achieve the overall best outcome for patients and for the company within a global regulatory environment and integrated industry ecosystem, doing the best to balance decision criteria with risks, recognizing it's not possible to make something 100% safe, and that the complexity and ambiguity of ethical decisions requires collective wisdom and negotiation for best outcome. There's a quotation. So I think for most big decisions in the company, multiple departments, multiple stakeholders are involved. Generally, it's engineering, regulatory, quality, medical sciences, which is sometimes represents the clinician's perspective. I would say those are the big departments. Then obviously there's operations in terms of processing to make sure that we're not changing something that they can't act or that they can't actually make the product anymore. But certainly, all of our instructions for use, all of our design, all of our risk management activities, our change control, our quality system, all those things are reviewed by somebody in those departments. And then they're usually signed off by management in those departments. So it's in a very involved process, I think. Sometimes it's frustrating for people working in the industry because change is slow and calculated. And then sometimes it could take a long time for things to change because you have to involve so many people, so many stakeholders. But all of our major processes, from, again, like I said, design, engineering, risk management, quality system, all those things are reviewed by representatives from all those departments, and they need to sign off on it. So this differs differs from category D, there's a shift from reconciling the internal and external conflict to process of negotiation with many other perspectives and influences to find the best or good enough decision. So negotiation, the idea is to optimize to the best what you can do that's best possible, but recognize and now embracing uncertainty, the awareness there's often not one right answer, but takes collective judgment. So it's a process of negotiation. There may not be one right answer, whereas category D tries to find the right answer. Category E realize there's no one right answer. It's negotiation, but you want to make sure you involve all the stakeholders and reach an informed judgment. And then at our highest level, stewarding culture, our description is ethical engineering practice is stewarding an organizational culture that supports collaborative ethical decision-making within a highly complex ecosystem of industry, clinic, and government, ensuring the culture is open to improvements by inviting trust-based communication, encouraging learning from failure, shaping this culture by being exemplars and ensuring all relevant stakeholder perspectives are invited and considered in order to ensure the best ethical choices are made. These are typically positional leaders within the organization, but again, not always. So the vice presidents, directors, people, those kinds of people. Here's a quotation. At the end of the day, every action that we take is a reflection on ourselves as a person. Especially for myself, I feel in a position of leadership, people look to you to be that example of ethical behavior. So I don't know, I can say definitively that something I do is not based on ethics. I think people look to leadership as being the example of how they should handle situations, or really how the company handles situations, both from the standpoint of being fair and being challenged, hearing the ideas of others, acting with urgency, acting in the patient's best interest. All of those for me personally are facets of what I believe to be a direct representation of the company and how I try to conduct myself to be that example, and also to reflect my expectations of my team. So it differs from category E. So determining the optimize, or whatever the best we can do, ethical decisions is requiring a dynamic, functional organizational culture that encourages open, honest, inclusive dialogue, and a culture needs to be developed and managed within this larger industry ecosystem. So briefly then, our outcome space has 6 categories, which I like to organize into pairs. Category A, follow the rules and regulations. Category B also has this, hold each other accountable. So these are similar to the dualists of Perry's model, intellectual and moral developmental students. There's one right answer. Sometimes it may take a while to interpret, but we'll get to the right answer. Category C is advocating for safety and technical quality. That's the engineer's most important values. That's their job. But so D means, well, sometimes we have to navigate through conflicting values. So this is, I think it's similar to multiplicity in Perry's scheme. Ethics has multiple or conflicting values and navigating to find the right answer that honors these values. And E, negotiating with multiple stakeholders, while exercising, F is exercising inclusive leadership. So I think of this like relativism in Perry's model. No one answer is always right, but we can negotiate to reach consensus and commitment. I want to say the model is not intended to be developmental. It doesn't mean that all engineers start at level A and go to category A and go to category F. We had younger engineers up at the the middle categories. We had older engineers at the lower categories. So it's not developmental, but there is a sense in which the later categories are more expansive in some way. We defined a couple of these dimensions of variation. So the understanding the role and responsibility on the horizontal axis varies from following to ensuring to improving procedures, to applying knowledge to the light of socio-technical complexity, to influencing, negotiating, and stewarding a culture. And then the second is understanding the system in which people work, from a set of rules and protocols and procedures to be followed by each engineer as an individual or as a team in their job activities, category A, to the complex organizational culture and management of a company embedded in a larger industry ecosystem with lots of players, right? Regulatory agencies, clinical healthcare institutions, professional society, and so on. So that's our outcome space, the 2 dimensions, vertical dimension of understanding the system, the horizontal dimension of understanding roles and responsibility, starting from accepting the the context, the regulations and rules. The second is questioning because you have conflicting values. And then at the highest level, which encompasses all of these, cultivating a culture of respect, inclusion, and integrity in the organization and industry. Okay, so those are our labels. And if you have, we'll talk about having better labels if you want. So I want to briefly now talk about the relations, how our results relate to the literature, and then how we can, what the implications are for practice, ethics education practice. So, well, it's well known in the business ethics literature that there's some interaction between the individual and situational practice in moral behaviors. Sort of obvious, but you have to document it. And then Davis found that engineers were expected to go to the mat in advocating for technical priorities. And we certainly saw that in category C, but we saw other kinds of experiences that engineers have had with ethical practice. So how we go beyond our current understandings, our previous understanding of ethical practice, we're going beyond individual compliance with rules and regulations and procedures and professional responsibility, traditional notions of ethics in professions, to collective efforts that involve multiple perspectives and stakeholders. Our conclusion is that engineering ethics is fundamentally collaborative. Let me say that again. Our conclusion, basic conclusion, is engineering ethics is fundamentally collaborative. So most prior work in ethics education is focused on individual decision-making. Nothing wrong with that. But if you get into real practice, there are a lot of people involved all the time. Starting in category B, even in category B, the engineers recognize their interdependence with other stakeholders. And so what this means for ethics education practice, how we can use these ideas, is to think differently about how we educate students, not just for individual decision making, but more collaborative kinds of skills. So we need instructional activities that provide authentic experiences with collaborative moral problem solving, which is the process of reconciling conflicting perspectives through negotiation. Right, so we should include some collaborative moral problem solving in addition to individual responsibility. Oh, and I love to cite myself. It adds to my citation count. If I don't cite myself, I can't expect other people to cite my work. Please cite my, you don't have to read the paper. In fact, there's some papers that are, and especially my early education research papers, they're so bad, I forbid my graduate students from reading them. But then, of course, they go and read them. Okay, so yeah, I wrote this paper on collaborative learning in engineering ethics. But this can happen in any other, any other professional ethics instruction. So nearly every participant emphasized that there were no aspects of engineering practice that did not involve ethics. So engineering instructors should stress that ethical issues do not arise in exceptional cases such as disasters, but are relevant to every engineering role and context. So that means we should think about multiple learning contexts in which ethics might arise. I mean, I happen to like stories of disaster cases because they're memorable. But if we also want to give students make sure they know that it isn't just in these exceptional cases, then we need to show that these kinds of ethical issues arise in all aspects of engineering, every engineering role and context. Now, our ethics instruction might need to be different for different roles. So ethics training might depend on the engineer's roles and responsibility. So engineers who experience ethics as stewarding culture generally had leadership roles. And certainly the business ethics community is very good at ethics for business leaders. And we might think actually draw on some of the things that they're doing to when we're talking about engineering leaders. So, I'm interested in engineering education at all levels, mainly at the college and university level, but even ongoing education, continuing education, which I've actually done now. I've done a few sessions for real live engineers, and it's kind of nice to talk to them too. Okay, so skills. So, you know, just like being able to determine reasons for regulations in categories A and B. The engineers emphasize understanding the intentions of the regulation so that they can be interpreted appropriately. Right? Things are often ambiguous. They don't cover all cases. Okay, what's the intent here? How can we honor the regulation within our reasonable interpretation of them? Another skill, when knowing limits of competence and when to get help to interpret regulations. And similarly, there's an idea of assisting others, giving help to others. It's reciprocal. Right? If you get help from other engineers, you should be willing to assist others when they seek help, right? So it's a basic skill, knowing the limits, and that's okay. It's another collaborative environment. Categories C and D, learn how to advocate for important values. I like the Giving Voice to Values program of Mary Gentile. There's now an engineering version of that up on the Online Ethics Center website. But developed in the business ethics community first. So this is another important skill, being able to articulate your values in a way that could be persuasive, but also being able to understand the perspectives of others. I really feel that maybe the most important skill I'm trying to cultivate when I teach engineering ethics is perspective taking, right? There are legitimate opinions and values. They're different from your own. They're legitimate. And then negotiating to create, win-win solutions, collaborating with others to find solutions that honor all relevant moral values. Oh, I got to cite myself again. This is a good paper. I recommend Loui 2009. If you want, I can give you all the references. This is about an extended role play that lasted 2 weeks, but it's a small honors class. They had to go negotiate conflicting values. So limitations, all the participants came from the health products industry. We're doing good on time here. That's convenience. I mean, we had connections to the health products industry. The data came only from the interviews as participants recalled their experiences. We had no observations or documents to triangulate or check on participants' stories, but that's a fundamental assumption that the participants can be reliable. The 4 interviewers might have applied the semi-structured interview protocol a little differently. So different interviewers might have asked for different follow-up questions. Oops, I'm sorry. Let's do that. No participants mentioned macro-ethical issues, policies, such as social justice and access to health products. That could be a limitation of the interview protocol. We didn't specifically ask for that. We're just talking about ethical engineering practice, just like that. So should we be teaching macroethical issues in a course for engineering ethics for emerging professions? At least macroethical issues should be, we can talk about whether it's as important as a microethical issue. Everything they talk about is sort of individuals and within organizations and not big social policy question. And I'm talking in a department that really focuses on public policy. So, the results are descriptive and not prescriptive. Or normative, so it's not how ethics should be in practice, but just how engineers experience it. And as I said, we're not implying a developmental trajectory. So there are some mostly junior engineers in category A, mostly senior engineers in category F. We don't mean to imply there's a development as engineers gain experience. Okay, so in summary, we use phenomenography to investigate variations in the ways engineers experience ethics. We use the Q3 framework for trustworthiness. Our outcome space has 6 categories that vary across 2 dimensions, and the results expand our understanding of engineering ethics in practice and provide guidance for instructors. Thank you very much for coming, everybody.
Thank you so much, Michael. We really appreciate it.